My name is Shu. I'm a solution architect at Databricks. And thanks for coming to this session. I know you have lots of other options, so thanks for coming. And today, me and Scott is going to talk to you about easy button, auto CDC. And I'll let Scott introduce himself when his part comes up. And we're going to talk about auto CDC, which is an easy button for streaming data flows and batch data flows. Now, what is auto CDC? I know at Keynote, you heard CDC represents continuous data corruption. That's not it. It's continuous change data capture. Yeah. Auto CDC is automatic change data capture. It basically is a declarative framework so that you can capture your change data without reasoning, with a complex merge statement, and then complex logic, writing hundreds of lines of SQLs to sort out a sequence, data arrivals, and then duplication. And auto CDC also has built in a slow change dimension 1 as well as slow change dimension 2 support out of the box. So again, you don't have to reason that in your merge statement. So slow change dimension 1 and slow change dimension 2, these are really not new to everybody. But I just want to quickly capture. Slow change dimension 1 means I just want the latest and greatest. And slow change dimension 2 means I want the full state, the full life cycle. And a typical, think about very, very easiest thing to reason about when you shop, right? You add something to your cart, and then you decided to put it back and empty your cart. So that is a lot of information that you wanted to work with. You don't want to just write it off as a slow change dimension 1. But there are situations both slow change dimension 1 and slow change dimension 2 make sense. And now, what is auto CDC with Snapshot? So, as data engineer, all of us have written change data capture, and you find yourself in a situation, you're just at the mercy of your source system. You don't have a perfectly changed data sequence passed to you as the source. Now what you do? So that's exactly what auto CDC from Snapshot implements. It basically compare your snapshots and infer what are changes. So you don't have to put in like extensive application just to capture that change sequence. We're going to talk a lot more about how the snapshot infers the change sequence. But briefly here, if it's in the source, not in the target, that means an insert. If it's in the source, in the target, and you have the key defined, that means an update. So that's no big deal there. But then the interesting part is, if it shows up in your target, but it's disappeared from your source, right? You can infer that as a delete. And we're going to talk more about the delete and nulls, but delete is usually the tricky case. When you do your usual ingestion, upserts, normal, right? Business as usual. Deletes is what we pay attention to. So why we have an auto CDC, we already have a merge for your coding ninjas. I can write this, right? The auto CDC is just an easy button for you, implement things out of the box. It defines your primary keys or your unique keys, so you don't have to worry about deduplication. It'll do that for you. It defines a sequence column, which then sorting your records for you, so it handles late arrivals out of sequence for you out of the box. And then the thing about the slow change dimension 1 and 2 is essentially just like a parameter you define, so you don't have to even reason about it. You just need to say, oh, I want a SCD1 or I want SCD2 declaratively. And we have a blog publishing out about auto CDC versus the performance of merge. You'll see that in our blogs, but just quickly list out here. Because auto CDC is implemented out of the box, that we have optimize implementation versus your handwritten merge statements so that your code actually runs very efficient. And then you would have much less code and then much less storage when you needed to do the merge, scanning the source, scanning the target, compare the difference. And then also that's why it has way better throughput as well as lower cost and then better SLAs. Okay, so we talk about all the upsets and normal, business as usual. Let's take some deep dives into deletions and nulls. These are, I like to call it like offload the confusion. We get clarity. How exactly deletion behave in the situations? So in a streaming context, which is AutoCDC deletion behavior, and then batch context, which is AutoCDC from Snapshot deletion behavior. We'll talk about these two, and then we'll talk about the nulls. How do we update our results with the nulls intentionally? Like we don't want to corrupt the data when the null is just unintentional. I have some source send me nulls, I end up corrupting my target with nulls. So that's unintentional null update. So we'll talk about how we handle those. AutoCDC in a streaming context, when deletion comes, AutoCDC API let you just say apply as delete. So this at itself is easy. But the complex part is you may not have control if your source is going to give you a tag in your data that says, okay, if this operation says delete, apply as delete. So that's how the AutoCDC API works. If you are able to tag it, says, okay, this row has an operation that is a delete. When your target comes, AutoCDC says, apply as delete. Now the behavior of slow changing dimension 1 is it's a deletion. This record ceased to exist as if nothing ever happened. And slow change dimension 2, however, it says, I'm going to mark you as delete, but mark when it delete happened. So give you the full context. The AutoCDC from Snapshot, the deletion behavior in a batch context, we mentioned a little bit about how the engine infers it's a delete because it shows up in your source snapshot, but then it shows up in your target snapshot, but then it disappears from your source. So the API detects that as a deletion. It will then delete from your target based on if you want it to be a slow change dimension 1, it deleted it. Just the record doesn't exist anymore. Or you do the slow change dimension 2, mark up when this record is deleted, so you have a full life cycle of that event. The behavior of STD type 1 and STD type 2 for deletion in streaming and batch context, they're the same. But then how the deletion is detected and inferred, that's the difference. Okay, so for nulls, I don't know how many of you had unintentional nulls in your data ingestion pipelines. Now you can have fine-grained control of, you wanted to tell the API your intention, when I wanted to update, when it's a null value, and when the null value does not correct my target data. So there are two solutions to avoid this like ignore updates, ignore null updates, the all or nothing kind of scenario. The first solution is if you know exactly that you have some subset of columns that they will never take nulls. These are golden records. Only if there's some actual data come in that I'm going to keep these and then ignore any of the nulls. You can explicitly set it here. You can say ignore null updates on these columns. So this is one way if your use case happen to fit into, you know exactly what columns that you wanted to ignore the null updates. And then the second solution is, this one is tricky because it depends on your source system. You can actually make a mark. It provides you a status column, meaning, for example, if your pipeline, you have many heterogeneous sources. Some source will send partial data, some source send another subset data. They all know that I'm going to only send you column 1 to column 2, and the other sources, I'm going to send you column 3 to column 4. They will mark it for you so that you know you can do row by row. If this is from this source, I'm going to trust the status column so that any data from these columns are updated from source 1. And any data from like the status column markup coming from a different source. So that basically gives you a multi-source, row by row kind of control what data that you wanted to honor the nulls or avoiding unintentional nulls. Okay, so with that, I'm gonna pass it on to Scott. He's gonna introduce himself, and he's a real ninja for a Spark declarative pipeline. And I've been working with him for like a few years.
Leave it on that slide.
You want me to go forward?
I don't want to spoil my next slide, so just.
You want me to go forward?
Nope. All right. Nice job, Shu.
Thank you.
Do you want your? Okay, we're doing good on time. Our goal is to leave plenty of time at the end for questions. We're hoping to get some good conversation going at the end, so I'll go through my part and then we'll do that. I do want to set some context. I'm going to show you a couple demos, and I just want people to have some context of what it is I'm trying to show, because AutoCDC has many different features, as you've seen. There's just all kinds of features and knobs to twist and turn, and each of them has applicability in different scenarios. Some of those are applicable when you're reading change data. So if you're consuming change data from a source, like a Delta Lake table that has change feed enabled, and you're consuming change data, you can use AutoCDC with some of those change attributes to handle updates in your target. That is not what I'm showing you. So I just want to be clear, if you're looking at my demos and going, well, where's the change data? It's not there. What we're showing is how you can use AutoCDC when you're just reading the source data itself. So you don't have those change records, you just have the data, and AutoCDC will automatically derive what has changed by comparing the source to the target. So you can still get change data even though you're not reading a change feed. So that's the two examples I'm going to show you. I'm Scott. I'm a data engineer at 8451. 8451 is wholly owned by the Kroger Company, a national grocery retailer. You may know them by other names, Fred Meyer, Dillon, Smith's. They have about 15 different banner names across the country. So national grocery retailer. Anyone who's familiar with dimensional data modeling, facts, dimensions, that sort of thing, good, because that's the context of what I'm going to talk about. I'm going to show you the first example is using AutoCDC in a fact table data flow, and then the second example is using AutoCDC in a dimension table load, okay? So in the first example, we're going to use a readStream statement. So the first example is going to be a fact table loaded with readStream. Second table, dimension table loaded with just a regular batch read. So why use readStream? Because Scott loves readStream. That's why you should use readStream. So if you've used readStream at all, you're familiar with the functionality. If not, let me describe it in a very simplistic way. So readStream simply keeps a checkpoint so it knows what's the last data you read upstream. So you read some data, you write those rows, the checkpoint is advanced. You come back later, you read some new data, it's going to pick up at the checkpoint, it's going to write that data, advance the checkpoint. The beauty of that automatic checkpoint advance is it gives you guaranteed once delivery. The checkpoint's not advanced until the write succeeds. So if the write fails, checkpoint is not advanced, and the next time you call readStream, you get that original data from your last checkpoint so you can reprocess it. So automatic reprocessing, guaranteed, once delivery. Any of you that have built batch data flows, which is probably all of you because we've been doing that for decades, you know the concerns of building a batch load incremental system. You're constantly worried about, did I get too many rows? Did I get not enough rows? Did I double load any rows? Did I miss something? When you use readStream, Spark Structured Streaming, automatic checkpointing, all those edge cases go away. You don't code for them, you don't worry about them, go to sleep and don't worry about it because it is built in, guaranteed, automatic. So use readStream. There's particular sets of data where readStream is particularly advantageous, And that's in your typical fact data, which I'll call continuous data. Continuous data are events that happen all day long, like sales transactions, clicks, events, any kind of telemetry, that stuff that logically has no beginning of time, it has no end of time, it's just an unbounded continuous flow of data. So readStream works particularly well there. Now historically, readStream was often referred to as an append-only operation, because in its simplest form, you would read some data, write the data, go read more data, write the data. By introducing AutoCDC into your data flow, now you can control how the data is written to the target. So you can conditionally do inserts, updates, and even deletes on the target table, even though you're using a readStream mechanism. So here's the first example I'm going to show you. So Kroger customers buying groceries. Kroger does somewhere around 8 to 10 million sales transactions per day. These transactions are streaming into Kroger's data center, into a streaming platform all day long. They come from in-store sales of shoppers buying stuff. You can order groceries for pickup at the store. They'll come out and load them in your trunk and check you out and you drive away. Or you can order groceries online for delivery to your home. Regardless how you get your groceries, a sale transaction is generated by a point of sale interface, and that sale is immediately streamed into Kroger's data center. So those arrive in real time. On my team at 8451, we want to consume Kroger sales and put them in our data mart to do all the sales analytics that our data scientists do. So this is, we built this Spark Declarative pipeline. It's doing a readStream on that Kafka topic via Azure Event Hubs, for what it's worth, and pulling those sales into our data mart. So let's take a look at the code for this data flow. One thing you're going to find about the code is it's declarative in nature, as is Spark Declarative pipelines, and it is surprisingly simple. As Shu mentioned, even though reasoning about is this an insert or an update, is it out of sequence or not, can be kind of complicated to think through, the code to implement this is surprisingly simple. You're going to see 3 pieces of code for each data flow. The first piece identifies the source data. So any query you can write, be it a SQL query or a PySpark data frame, either one, it's just a definition of a query against a source. So it's going to return a row set, right? Rows and columns of data. This is our source definition. The key thing here is line 4, spark.readStream. That's important because it determines which version of AutoCDC I'm going to use. So this is a readStream. The data in this case is pretty simple. It's coming from Kafka, so you just have a key and a value. The key is the unique identifier for the transaction, so you can think of it like a transaction ID. It's just a GUID that the point of sale interface generates to uniquely identify that transaction. And the value is just that big complex nested JSON blob that's got all the structure of the transaction in it, all the hundreds of attributes nested in there. The second piece is define the target table. So you use this statement, create streaming table. All I'm setting up here is the name of the table. I'm also specifying which schema, cataloging schema it's going to be in, but it gives the table a name, and then I set any table level properties. I'm not defining the schema here as in the columns because that's what's coming from the source. That's going to determine the contents of the table. I'm just setting up kind of a name as a target. This is where you're going to write the data. And please ignore line 3. This is some old code. I would not recommend you use partitioning. You should use liquid clustering instead, but this was an old snippet, so forgive me. So the third piece, this is the magic. So this is create AutoCDC flow. This is what connects the source to the target and defines the rules for the merge. So just these 3 lines right here are what's determining the whole behavior of is this a change record or not. So it's going to take the key, in this case the transaction ID, look in the target table, say does this key exist in the target table? If it does not, it's going to insert it in the target table. If it does exist, already, it becomes a candidate for an update. I say a candidate because it's also going to evaluate the sequence by. Since in a streaming data flow, reading multiple partitions from a topic, you're not guaranteed events arrive necessarily in chronological order, so you have to account for the fact that it is possible you could have gotten this transaction, version 2 of this transaction first, and then later got version 1, and you wouldn't want to overwrite that in your table. So the sequence, this timestamp in the sequence is coming from the transaction record, so it knows the timestamp of that transaction. So that controls just making sure that the target table always has the latest version of that transaction, and you never overwrite it with an older version. And finally, if you're astute with all this dimensional stuff, you're going to look at that and say, SCD type 1, Scott, you told me we're loading a fact table. Why am I using slowly changing dimension type 1 on a fact table? Well, what that really means is just a simple upsert, right? It just means conditionally do an insert or an update. So that pattern is just as applicable to a fact table as it is to a type 1 SCD. It just means it's a simple upsert, no history tracking and all that crazy stuff. All right, so that was the fact table streaming read. Now I'm going to show you how we use AutoCDC in a batch read scenario. So why use batch? Didn't Scott just say how much streaming is so awesome and you should just always use streaming? Well, you should if you can, but you can't always use a streaming read. Some source systems just don't support a streaming read, so you have no option but to read the entire source. And there are cases where even if the source does support a streaming read, streaming gets very complicated when you have multiple inputs. So if I got to read 3 tables and then do some joins with a foreign key relationship, trying to stream from 3 tables at once gets really complicated. You have to set watermarks and conditions on how long is each stream held in memory to make sure the join can find the record it needs to match to, and it gets ugly very quickly. So on a small set of data, you'd probably say, it's not worth the effort. Just read the entire data set. So dimensional data is usually relatively small, slowly changing, so it's not time series data where you're getting on and on new stuff. It's just a set of reference data or master data. In general, scanning the entire data source is usually not a problem. So that's the case here, an example I'm going to show you, and that's why we decided to use a batch read. So our example I'm going to show you is we're loading our store dimension. So every sale is associated with a store, either where you bought it or you picked it up or it was shipped out of. So the store is an attribute of the sale. So we build a store dimension to link to the sale. And I mentioned 8451 and Kroger. We're kind of 2 different companies, but same parent, but we still operate in 2 different Azure tenants. We used to be a separate company. So on the left, you see Kroger's Unity catalog. They have an Azure tenant. They have their Unity catalog. 8451, we have our own Azure tenant and our Unity catalog. So for us to share data back and forth, we use Delta sharing. So someone at Kroger is maintaining this list of locations, property locations, every physical property that Kroger owns. About 10,000 locations across the country. That's stores, distribution centers, fulfillment centers, office buildings. Any property they own is in this master database that they maintain. They share that to us through Delta sharing. So when I look at it, what I see are these, I think it's 7 views. So that's what they have shared to us. These 7 views, and they said there's all the location information, you go get it. So I got to join in a couple different passes, several of these tables together. So you can see why immediately I said, I don't want to readStream that. It's a view, it's not going to have the transactional consistency of a table. Trying to stream off of those, it's too much to reason about. And it's 10,000 rows. So just scan the source, bring it in, figure out what changed, and you're done. So again, here's our data flow. We're going to do a batch read on those 7 views, apply AutoCDC to detect changes, write that into a type 2 slowly changing dimension as our target table. Again, 3 pieces of code. There's the source, the target, and the merge mapping. So this is the source. Key thing here is on line 7, spark.read. Not readStream, spark.read. So a full table scan of the source table. Joining it with several of the other views in this little snippet and adding a few columns on there. So the second piece, define the target table. So I'm give it a name, I give it a few other properties. That gives me a target to write to. And finally, create auto CDC from snapshot flow. So that's what's different here. When you use a read, you're in batch mode, you have to use auto CDC from snapshot flow. So Shu on the earlier screen talked about auto CDC and how it compares snapshots. So it can be a little vague. Well, what do you mean by snapshot? Well, when you look at this statement right here, the target table is a snapshot of the data. You might call that the previous snapshot, right? It's what's currently sitting in the table. I've read the source. I now have a new snapshot. So I have the previous snapshot in the table. I have the current snapshot that I just read from the source. Snapshot meaning it's a full set of data. It's not, a micro batch or a part of a stream. It's a full set of the data. So the comparison here is simply compare source to target and figure out what's different. So again, the way it's going to do that's just with the key. It's going to take the location ID. Do you exist in the target table? Yes or no. If you don't, it adds that row to the table. If it does exist, it's going to overwrite it, update it. In this case, there is no sequencing because we're using a full snapshot of the data. That location's only in there once. So I don't have to reason about, part of a stream and did I read it before or has it come through again? Doesn't matter. Whatever's in that snapshot is the latest version of that. So it's going to overwrite the location in that case if it gets a match. Stored as type 2 SCD this time, so I get all my history tracking and normal type 2 SCD pattern. And then the other option is just if you want to ignore some columns for updates and not really relevant. Did I cover everything? Okay. So in summary, Shu talked about auto CDC as a method for conditional insert, update, delete on a target table. Again, you can use it with change data or without change data. The options and features are a little different, but it works in either case. We talked about streaming data flows, batch data flows, when it's advantageous to use one versus the other. And then a key thing we point out is there's 2 different versions of auto CDC. When you're using readStream, you use create auto CDC flow. When you're using read, batch read, you use create auto CDC from snapshot flow. They function mostly the same, but there are a few kind of nuanced differences in behavior. The way updates get sequenced are handled slightly different. Delete behavior is slightly different between the two. And if you are doing type 2 SCDs where you're setting a start at and end at for each row, the actual timestamp value will be a little different if you're using a batch read versus a stream read. I'm not going to get into all those nitty-gritty details. It's all documented. I just want you to be aware that there are some differences. So, okay. I think that clock says we have about 11 minutes left. Is that right? So I'd like to open it up for questions. We'd like to get some good discussion going. We do have a microphone here, so thanks, everyone. We'll stick around for a little bit if you want to talk more.